Schrodinger equations of motion, time independent Schrodinger equation. So consider a system of stationary waves to be associated with particle, and let consider psi of r comma t be the wave displacement for a particular time t and location r. Then we can write the differential equation for the de Broglie waves using the Maxwell's wave equation for 3 dimensions. Del squared psi equal to 1 by u squared into dou squared psi by dou t squared. So del squared can be written as dou squared by dou x squared, dou squared plus dou y squared plus dou squared by dou z squared. So multiply with psi. So we can write like this: 1 by u squared into dou squared psi by dou t squared. This is equation 1. Here u is the wave velocity. Then the solution of equation 1 contains psi. So we can write the solution for equation 1: psi of r comma t equal to psi naught into e power minus I omega t. This is equation number 2. Here psi naught is the amplitude at the point and position r. Then we have the coordinates x, y, z, so which is not depend on the time t. So differentiating equation 2 with respect to t. So equation number 2 is psi of r comma t equal to psi naught into e power minus I omega t. So differentiate this equation with respect to t. So dou psi by dou t equal to psi naught into e power minus I omega t. Exponent term doesn't change. So write it is like this: e power I minus I omega t. So differentiate this power term with respect to t. It will come minus I omega. Again differentiating with respect to t. So dou psi by dou t can be changed into dou squared psi by dou t squared equal to psi naught, exponent doesn't change, minus I omega. We can write it as it is. Then this exponent term can be differentiate. It will give minus I omega. So psi naught e power minus I omega t, minus into minus plus, I into I squared value minus omega into omega squared. So dou squared psi by dou t squared equal to minus omega squared. This psi naught into e power minus I omega t can be written as psi of r comma t according to equation number 2. So instead of this we can write it as psi of r comma t. So substitute this dou squared psi by dou t squared value in equation 1. So we can get this equation as 3. So but omega equal to 2 pi nu, omega equal to 2 pi nu, nu value c by lambda. Here c velocity of light, so here wave velocity u, nu equal to u by lambda. So instead of nu we can write it as nu by lambda. So find omega by u equal to 2 pi by lambda. This is equation number 4. So also this value that is del squared psi equal to dou squared psi by dou x squared plus dou squared psi by dou y squared plus dou squared psi by dou z squared. So we can write it in equation number 1. So substitute equation number 4 and 5 in equation number 3. So dou squared psi, so from this term left hand side, instead of left hand side using equation number 5, del squared psi equivalent to equation number 3 minus omega by u, omega squared by u squared, omega by u value 2 pi by lambda. So we can the whole put it as the square. So 2 pi by lambda the whole square into psi, remaining term psi, del squared psi equivalent to, so square these terms, minus 4 pi squared by lambda squared into psi. So it will come this side, del squared psi. So minus value becomes plus value. So this is equation number 6. So we know the de Broglie equation lambda by h by mv, lambda equal to h by mv. So substitute equation 7. So this 7th equation, so substitute equation 7 in 6. So instead of this lambda, so lambda squared means h squared by m squared v squared. So equation 9 in 1, del squared psi plus 4 pi squared by h squared by So this is lambda squared value in plus into psi equal to 0. So for del squared psi plus 4 pi squared m squared v squared, it is going to numerator m squared v squared by h squared into psi equal to 0. This is equation number 8. We know E and V are the total energy and potential energy of the particle. So we can write it as E equivalent to kinetic energy plus potential energy. Kinetic energy value half mv squared plus potential energy value V. So E, so keep it half mv squared this side, V it will go that side, left hand side. So E minus V equal to half mv squared. Again 2 into E minus V equal to mv squared. So multiplying by m on both sides. So 2m into E minus V. So just rearrange the above equation. 2m into E minus V, m into m squared V squared. So substitute this equation in 8. So instead of this term m squared V squared. So del squared psi plus 4 pi squared by h squared into m squared V squared, instead of m squared V squared 2m into E minus V, 2m into E minus V into psi equal to 0. Del squared psi plus 2 into 4 8 pi squared m by h squared into E minus V into psi equal to 0. This is equation number 9. The above equation, so here there is no time term, so it is called time independent Schrodinger equation. So we know that h cross, that is it is a modified Planck's constant, its value nearly equivalent to h by 2 pi. So we rearrange this equation, h equivalent to Planck's constant value, h equal to 2 pi into h cross. So substitute this value in equation number 9. Del squared psi plus 8 pi squared m by, instead of h 2 pi h cross, 2 pi h cross into this E minus V into psi equal to 0. Del squared psi plus 8 pi squared m by, square these three terms, 4 pi squared h squared into E minus V into psi equal to 0. So rearrange this equation. Del squared psi plus 2, so 4 2 times, so 4 2 4s are 8, so 2 times 2m by h cross squared into E minus V into psi equal to 0. This is equation number 10. So Schrodinger equation for a free particle. Suppose the particle is free, the potential energy equal to 0. So V equal to 0, substitute this V equal to 0 value in equation 10. It will modified as del squared psi plus 2me by h cross squared into psi equal to 0.